In this video, I want to be talking a little bit about perimeter. Perimeter is the first topic that's going to be covered in this next measurement unit, and I know we've covered it pretty extensively over the last few years, and most of you would have a pretty good idea of what perimeter is, but just for revision purposes, I'd like to go over it again. So I'd like to begin by introducing what perimeter actually is as a definition. Now, perimeter as a definition is simply the distance around the outside of shape. Okay, the distance around the outside shape, or the outside of any two-dimensional shape. I wanted to introduce you to one particular definition, and that is this word over here. This word, polygon. This word is going to crop up time and time again in this unit, and it's really important for you to understand what it means. All a polygon is a two-dimensional plane shape that's got straight edges and vertices. Okay, what vertices are basically just the points or the corners between both of those straight edges. So, you know, anything that doesn't have a straight edge is not defined as a polygon. So things like circles, ellipses, things like that are not polygons because they do not have straight edges, and they definitely do not have vertices. So that is the first term that I want you to remember, and that is a polygon. Now I'm going to draw a polygon here. I'm going to just draw any shape over here. Now this has got 5 sides, so this would be defined as an irregular pentagon. Now penta means 5, so this being a 1, 2, 3, 4, 5-sided shape would be defined as a pentagon. It is not a regular pentagon, however, okay, because a regular pentagon has got 5 equal sides. This one does not obviously have 5 equal sides, so it is defined as an irregular pentagon, okay. But I am going to put in couple of things, and that is these things over here. Now what these lines on these sides represent is that these two side lengths are equal. So in this case I can put down a length on one of those sides, and having the lines on both sides means that both of those sides are going to be equal. So I only have to label one of the sides, and I automatically know the distance of the other side as well. So I'm going to need to label the other 3 sides, and I'm going to say that this is 3 centimeters, this is 5 centimeters, and I want to put this as 4 centimeters. Okay. Now the way I like to think about perimeter is I like to visualize the situation. Whenever I do maths, I like to visualize it in an everyday context. Okay, so I like to put myself in that situation because it's easier for me to understand the whole context of the problem that way. So let's say perimeter, I am this little person standing on one of the vertices of this 5-sided shape. Okay. Now I want to imagine myself walking around this outside, the outside of this shape. So here I am walking around the outside of my shape, and I've gotten back to where I started from, and I ask myself the question, what distance have I walked? Okay, the distance that I've walked will give me the perimeter. Okay, so that's how I want to remember how I work out the perimeter of my shape. So in this case, perimeter represented as P would be 2 centimeters. Okay, so 2 centimeters plus 2 centimeters. Okay, so we got 2 plus 2, and then the rest of the side lengths are 3, 5, and 4. So we've got plus another 3, plus 5, plus 4. So I've gone a total of how many centimeters? So let's work that out. So we've got 2 plus 2, that's 4. 4 plus 3, that's 7. Plus 5, that's 12. Plus 4, that's going to give me 16. So I have walked a total of 16 centimetres. So the perimeter of my shape is 16 centimetres. Now this is an irregular shape, so really it's pretty much just trying to figure out what all of the lengths are of each of the sides and adding them all up. But this is how we do it for irregular polygons. How would we do it for regular polygons? We would do it exactly the same way, except the regular polygons, because they've got regular shapes and they've got regular kind of properties, we can define them using particular formula. I generally just like to use the method that I've just shown you here, because that way I don't have to remember too many formula, but there are those formula available to us should we need to use them. And in the next clip, I'm going to show you what those formula are and how we obtained them for all of our different regular polygons.